Okay, our last ICE problem, number 25, is that here's our equilibrium system. Carbon dioxide gas plus hydrogen gas is in equilibrium with carbon monoxide gas and water gas, or water vapor. These initial amounts were given in moles, and they must be converted into molarity. They tell us the vessel is a 2.000 liter container. So this is very straightforward. The concentration of each of these chemicals that were given will simply be the moles that were given divided by the volume of the container, and that'll give us our molarity. So carbon dioxide, 0.100, hydrogen gas, 0.05000, and water at the beginning, 0.08000. Notice they didn't tell us anything about this one, the carbon monoxide. So that one is going to be 0 at the beginning. That equilibrium, they just give us the molarity straight. We don't need to convert anything. So that means we are ready for an ICE table. So part A of your question is using the ICE table. And we know these concentrations. We just calculated these and we were given the one in the bottom. So then the question is, how do these things change? First of all, the direction, since there is 0 carbon monoxide, it must create carbon monoxide to get to equilibrium. And we can see from the equation, it's a 1 to 1 to 1 to 1 relationship, so that'll just be plus x. It'll also be the same, plus x for water, and it's going to be losing hydrogen gas minus x and carbon dioxide minus x. So we actually know this number at equilibrium, so we can actually determine that it's not x, it's 0.0056. So that means this one will also be plus 0.0056. And on the reactant side, it will be losing the same amount. So I just evaluate each column, and my equilibrium concentration for carbon dioxide is 0.0944 moles per liter, hydrogen gas 0.0444 moles per liter, and for carbon monoxide 0.0056 moles per liter. And we already were given what it was for water. So to answer part B, we have to make our equilibrium expression and then just substitute in. Once we substitute the numbers in, we find out that Kc for this system is 0.114. Again, no units. I ended up with 3 digits down here in my answer because when I started looking at numbers I was given at the beginning, the first numbers in the initial column all have 4 significant digits because these trailing zeros are telling me that it was measured all the way down to that place. The other number that was given to me goes only down to the 4th place after the decimal. It only has 3 significant digits. So I choose the smallest of them, not the 4s, but the 3s, and that's why I picked 3 significant digits for Kc. The last question, part C, wants to know if you can figure out what Kp is from this. And this is a little bit of a tricky one, but not much. Initially, you might think that, oh, my equation to turn Kc into Kp has to have the temperature. And I don't have temperature, so I'm stuck. But that's not the case, is that you can find it. And this is the key thing, that delta N is 0 in this case. So since delta N is 0, that means you put a 0 as an exponent up here, and anything raised to the 0 is 1. So Kp equals Kc, because that whole term turns into 1. And they're both 0.114.